हेलो स्टूडेंट्स। अभी हम जैक द्वारा जो मॉडल क्वेश्चन पेपर आपके पास प्रस्तुत किया गया है उसका सेट नंबर 2 को कंटिन्यूशन कर रहे हैं। लास्ट क्लास में हम क्वेश्चन नंबर 8 तक सॉल्व किए थे। अभी हम क्वेश्चन नंबर 9 से शुरू कर रहे हैं। क्वेश्चन नंबर 9, क्वेश्चन नंबर 9 ये कह रहा है कि डिफाइन क्रिटिकल एंगल, राइट एन एक्सप्रेशन फॉर द क्रिटिकल एंगल एंड राइट ए कंडीशन फॉर टोटल इंटरनल रिफ्लेक्शन टू टेक्स प्लेस। क्रिटिकल एंगल ये घटना अपवर्तन से संबंधित है और ये तब होता है जब प्रकाश किरणें सघन माध्यम से विरल माध्यम में प्रवेश करती है। जैसे कि हम लोग जानते हैं कि जब प्रकाश किरणें सघन माध्यम से विरल माध्यम में जाती है तो ये अभिलंब से दूर हट जाती है। ये इस स्थिति में एंगल ऑफ इंसिडेंस है, ये एंगल ऑफ रिफ्रैक्शन है। अब एंगल ऑफ इंसिडेंस को अगर बढ़ाया जाए तो ये धीरे धीरे झुकता चला जाएगा। अल्टीमेटली एक ऐसी स्थिति आएगी जिस स्थिति में एंगल ऑफ इंसिडेंस जो होगा उसके लिए एंगल ऑफ रिफ्रैक्शन आपका टोटल ये हो जाएगा, मतलब 90 डिग्री हो जाएगा। मीन्स जो रिफ्रैक्टेड रे है इट विल ट्रेवल in the contact surface of the two medium। इस अवस्था में जो एंगल ऑफ इंसिडेंस है उसी एंगल को हम लोग क्रिटिकल एंगल कहते हैं। इसलिए हम लोग इसको इस प्रकार से डिफाइन कर सकते हैं कि द क्रिटिकल एंगल इज angle of incidence during the refraction takes place when the light travels from denser medium to rarer medium for which the angle of refraction will be 90 degree. It is denoted by C. This is the answer of the first part, question number A, 9A. 9B. As you know, mu is equal to sin I by sin R. Mu is equal to sin I by sin R. That is, it is the 2 mu 1. 2 mu 1 is equal to, that is, this is the medium 2, this is the medium 1. Then the light is coming from medium 2 and enter into the medium 1. That value is sin I by sin R. Sin I by sine r. Here I is equal to c and r is equal to 90 degree. That is sine c by 1. Hence 1 mu 2 refractive index of this medium with respect to this medium, 1 mu 2 is equal to 1 by sine c. The expression for the critical angle. Question number C. Write the condition for the total internal reflection to take place. The necessary condition, for total internal reflection is the angle of incidence should be greater than the critical angle when light travels from denser medium to rarer medium. This is the answer of your part C. Now I shall discuss about the question number 10. Now question number 10. It is distinguish between conductor, insulator and semiconductor on the basis of the energy bands. On the basis of the energy band, actually according to band theory, the electrons are situated in two bands. Number one, valence band, and number two, the conduction band. If the energy gap between the valence band and conduction band is high, then the electron cannot go from the वैलेंस बैंड टू कंडक्शन बैंड. वो वैलेंस बैंड से कंडक्शन बैंड में जा नहीं पाता है जब एनर्जी गैप ज़्यादा हो जाता है. जब एनर्जी गैप कम होता है 1 इलेक्ट्रॉन वोल्ट के बराबर, तो थोड़ा सा एनर्जी, एक्सटर्नल एनर्जी देने से ये इलेक्ट्रॉन जो है सो वैलेंस बैंड से कंडक्शन बैंड में चला जाता है. तो और एक कंडीशन होता है कि जब ये दोनों के बीच में एक ओवरलैपिंग होता है, मतलब जहां से वैलेंस बैंड खत्म हो रहा है उसके पहले ही कंडक्शन बैंड शुरू हो जा रहा है. एनर्जी का जो बैंड है वो कंडक्शन बैंड उसके पहले ही शुरू हो जाता है. इस प्रकार से बैंड थ्योरी के आधार पर हम लोग इंसुलेटर, कंडक्टर एंड सेमीकंडक्टर को डिफाइन कर सकते हैं. तो हम इसमें लिख सकते हैं इन कंडक्टर द valence band and conduction band overlap to each other. Hence no energy gap. no energy gap. In semiconductor, the energy gap between valence band and conduction band is only 1 electron volt. In insulator, the energy gap between valence band and conduction band is very high. Now we can explain it on figure. This is the energy of the valence band. This is the overlapping position, energy of valence band. This is the energy in the conduction band, and this is the overlapping position. It will be conductor. For the semiconductor, this is the energy gap. It is 1 electron volt. It is the valence band. It is the conduction band. And it is your semiconductor. And very high. That is the energy gap. Very high. It is your valence band. It is your conduction band. Hence, on the basis of the band theory, we can explain the conductor, semiconductor, or insulator as follows. In question 11, A. Draw phasor diagram for series LCS circuit. Write expression for the impedance. Section B. Write expression for the impedance of the series LCS circuit. And what is the phase difference between the current and voltage in series LCS circuit? Now, question number 11. The phasor diagram of LCS circuit A is like this. This is the voltage on the resistor, this is the voltage on the inductor, and this is the voltage on the capacitor. And this angle phi, it is not theta, it is phi, is the phase angle. Hence, the phasor diagram of LCR circuit is like this. Its impedance, second B, impedance. Impedance means total resistance provided by the LCR circuit in series. And this impedance is denoted by Z is equal to A naught by I naught, and that will be equal to under root R square minus XL, R square plus XL minus XC whole square. This is the impedance of this LCR circuit. See, what will be the phase difference between the current and voltage, that is defined by the phi, and the phase difference is phi is equal to tan inverse XL minus XC by R, XL minus XC by R, where XL is the inductive reactance, XC is the capacitive reactance, and R is the resistance of the resistor. Hence, this three questions can be solved like this. This is the question number 11. Now, in question number 12, it is the level graph to show concerning photoelectric emission. फोटोइलेक्ट्रिक एमिशन से संबंधित उत्सर्जन को दर्शाने के लिए है। पहला बोल रहा है प्रकाश विद्युत धारा का विकिरण की तीव्रता के साथ बदलाव, मतलब what will be the variation in the photocurrent when intensity of the incident radiation changes. It is the question number 12A. The intensity, if you the photoelectric current is directly proportional to the intensity. The photoelectric current is directly proportional to the intensity of the light. Hence, if this is the intensity, this is nu, it is the intensity I. This circuit intensity. Then this is the photocurrent. Then this graph will show the variation of the photocurrent with respect to the intensity. Number 2, variation of photocurrent with accelerating and stopping potential. When the potential of the positive terminals are increased, the photoelectric current increases and get a saturation after a certain value of the potential, positive potential. Means if the accelerating potential will be increases, the electric current, photoelectric current will increase it and it will attain a saturation, and hence we can give it as like this. This is the potential and this is the saturation current. It is the photocurrent. This is the saturation current. It is the part B. Now for part C gives variation of stopping potential with frequency of incident radiation. Incident radiation, if the frequency of the incident radiation increases, the stopping potential increases. The fact is that. Hence, this is for frequency nu 1, this is for frequency nu 2, this is for frequency nu 3, and it is the stopping potential 1, it is the stopping potential 2, it is the stopping potential 3. Here nu 1 is greater than, nu 3 is greater than nu 2 is greater than nu 1. Hence, it will also attain the saturation current, but as far as the frequency of the radiation will increase, its stopping potential will be reduced, and hence this is the question number C part of the question number 12. Now question number 13. What is rectifier? A rectifier is a device which converts alternating voltage or alternating current in direct voltage or current. This is the first part. What is the rectifier? Second part, an AC input signal frequency 60 Hz rectified half wave and full wave. Half wave and full wave rectifier, write the output frequency. For the half wave rectifier, the output frequency is equal to the input frequency. And for output, this is the A, this is the B. For half wave rectifier, the output frequency is equal to input frequency frequency. Hence, it is output frequency is 60 Hz. Output frequency is 60 Hz. For full wave rectifier, full wave rectifier, the output frequency is double of input frequency, and hence it is 120 Hz. This is the answer of your 13. Rest question will be given in the next videos. I hope all of you will be sincere and observe my videos. Thanking you.